an alumnus of Delhi College of Engineering, Mr. Dham is often referred to as the father of the Pentium chip for his work on the development of Intel's Pentium microprocessor, which revolutionized the world of computing in the early 1990s.
Now, designing chips is a very, very essential element of the semiconductor ecosystem that we talk about here every day. I think there's a lot of focus on fabs, which is process technology and supply chains, which is very critical. That's for manufacturing of the chips, and also on the back end, technology of assembly, packaging, testing. Maybe I should just go ahead and first give you a little simple tutorial that I found when I talked to many people here from different walks of life. There was not a clarity as to what is it that we are trying to do. What is this? There's so many pieces of this puzzle that it wasn't clear how do they fit together. So I actually sat down yesterday and put together this slide. So I apologize. It's a very simple PowerPoint that I put together myself, so it doesn't have all the colors. But as you can see, you start with an idea. And I took the idea of Pentium because that's the idea that I was involved in. So it was easier for me to describe to you how we created Pentium, for example. So you start with an idea of what you want to do. So you want to create a chip that will go into a personal computer, which is the end product. As you can see, at the end of this cycle is a personal computer. And the beginning of this cycle is a bulb. Bulb is the idea. So when we sat down to say, okay, if the chip has to go into this computer, one of the most important thing is what speed should it have? How fast should it be? How much power should it burn? Because you can't really have too hot a chip running into a system, especially if computers became laptops became tablets, and then tablets became iPhones or smartphones. As you can see, one of the things that really kept on going down was the power, because you cannot have in your pocket a computer that is really burning too much heat. Third thing, of course, is always cost. So all innovations are constrained by cost. Even if you have great ideas that you can think of, sometimes you have to incrementally implement them step by step over a period of time, because the market has to catch up, the consumer has to catch up to give you the cost, buy your product, because they can't afford to buy something if you put all bells and whistles into your very first product that you make, because that will become too expensive, it'll become too big. So this phase of design is called specification. So you have an idea and you put together specifications of that idea. So you can define what is it that you want to do. And then the third step is called chip design. And that's what all these gentlemen who are sitting here, they are ace chip designers. They are the ones who are chip designing. These are teams of people. They can do logic design, circuit design, then you do timing analysis to make sure you're really still meeting the speed goal that you had originally. So I'm going to oversimplify it just to give you a concept, an idea of what do we do here. Then we do a physical layout of the chip. So the circuits, which are all electrical, have to be physically, just like, literally think about the way a house is built. You go to an architect and he architects the house. Is conceptually, you tell them this many bedroom, this many bathroom, this is the living room, and then he physically lays it out on a blueprint, on a piece of paper. So we physically lay out this chip. And then we take that physical layout in a computer file, I call it CAD file, and we convert it into a photo mask. We think of it like a glass plate. So that whole chip now that is now in a physical form, the entire circuit is on a physical floor plan, is now replicated on this glass plate. And now imagine we have multiple of these glass plates that define the entire circuitry and logic of for example, in this case, it was a microprocessor. Now, this glass plate is the one that is sent to the fab. This is the one that goes to the fabrication area or the foundry or whatever other terminology you may like to call it. That's where those people receive this plate, and then they take this plate and they process silicon underneath it through various steps. So what do? They may do metal deposition, implantation, etching, photolithography, oxidation. So you see from the here, there's a start is a wafer. The wafer actually here shows some colors, but it's really a blank. It's a blank silicon wafer. It looks like a grayish kind of a thing. Then you oxidize it. Then you print on it using that glass plate the pattern that you want, which is a circuit actually. And then you etch in that pattern various places where you want to diffuse or implant various types of impurities. You know, Modi talked about conductor and he talked about insulator. So a silicon is basically an insulator. When you put different purities in it, you can make it a conductor or an insulator depending on what you want. So that's the reason for doing that, by the way, is very simple. At the fundamental level, it's a switch, an on and off switch. So we are putting on that die, maybe these days, 100 billions of these switches on a tiny piece of silicon the size of my thumbnail. Just imagine that. That's how fine the imprint of the photolithography is. In any case, then you connect them together with the metal. Then once that is all done, then you're basically done one part of the wafer fab. Then I just showed for completeness sake, once that is done, you need to wire bond it. That is, you need to connect this chip to the outside world, because if you ever open a computer, you'll see a motherboard and you'll see these chips and their names on it, but they're all connected to the motherboard with just a little bit of a wire bonding, a little bit of a welding. That's what that is. Die attach, polishing, encapsulation, then you test it, and then you package it, and then you basically have what I showed as an Intel Pentium. That's a package chip. You can't see the chip inside of it. You're only seeing a ceramic package outside. That is the output, and then that goes into the personal computer. So this is the whole cycle of the whole ecosystem, if you want to. And we want to create, by the way, for your information, in India, not just a fab to manufacture it, not just a design to design the chip, and not just the packaging to package it. We need to also think about how are we going to create the end product. Right now, all the end products in India, even though we are now celebrating the fact that Apple is here and they are manufacturing their iPhones here, and a lot of other iPhone manufacturers or smartphone manufacturers are now present in India. But remember, we are basically still getting the chips from somewhere else, and the fabrication is done somewhere else, and those are pretty high-end value chain items that we need to start doing here.